Okay. All right, cool. So as I said, I'm taking some of Unit 4 material and bringing it into this part of the course, right? So this is a Year 12 presentation, but I'm going to skip over sections that we're not going to cover in Year 11, okay? So what we are covering is what I've put on the board. Substitution reactions of alkanes, addition reactions of alkenes, esterification and oxidation of primary alcohols. So what we're not covering is oxidation of secondary alcohols. We're not covering amine and carboxylic acid, right? And we've already covered the last two. Cool? Don't worry about the term volatile. What is useful, though, is the term nucleophile. What does philic mean? Like, right? Or loving, yeah? Make sense? Right? So I am a chocophile. I am a lover or a liker of chocolate. Yeah? Not a chocoholic, right? That means I've got an obsession with chocolate. And an obsession with chocolate, I just really like it. Yeah? So a nucleophile, what do you think that means? Love the nucleus, right? So a nucleus is partially positively charged, right? So a good nucleophile is something that either has a negative charge or reaction pathways. So nucleophile is something, bases are really good nucleophiles. Hydroxide ion in particular, really good nucleophile. Yes, Lexi?
Is this pathways on our index?
It's not on the index. It's on my Year 12 index. I'll give you access to that, right? But I have put the link on the MS Teams page. Hydrolysis and condensation, we've looked at that before. Hydrolysis, breaking of bonds. Condensation is forming of bonds. Identification of key functional groups. We've looked at haloalkanes. We've looked at alcohols. We've looked at carboxylic acids. We've looked at esters. Fractional distillation, kind of skipped over that, right? We distill crude oil, mixture of hydrocarbons. We distill that by means of fractional distillation. It's when we heat up the substance and distill it or break it into parts according to their boiling point. Functional groups, halogen, we've seen that. Alcohol, seen that. Skipping over aldehyde, right? Carboxylic acid, we've seen that. Ketone, amine, amide, we're skipping over those. And ester we have seen. Here's all my images that I made. Just mentioned that already. Skipping over this, okay. Moving on. Viscosity, don't need to worry about that yet. Don't need to worry about that yet. Flashpoint, don't need to worry about that yet. Cool. So, substitution of alkanes. What's an alkane? It's a saturated hydrocarbon. Yeah? What's a saturated mean? Can't have any more hydrogens, right? So we've got a maximum number of hydrogens present, all single carbon-to-carbon bonds. So if I take a halogen, say chlorine or bromine, or even iodine, right, and take an alkane, put them together, nothing will happen unless I give the reaction ultraviolet light. Why ultraviolet? What do we think about ultraviolet? Who does physics? Yeah? Have you seen this before? E equals H. Have you come across that in physics? No. All right. What do you think E means? Energy. What do you think little f means? Good guess. It's not force, that'd be capital F. Yeah? F means frequency. Yeah? H stands for Planck's constant. Right? So the energy of a light form is equal to Planck's constant, which is a very, very tiny number, multiplied by the frequency of the light. So the higher the frequency, the higher the energy. Yeah. Yeah. So low wavelength, high frequency. Yeah. So the smaller the wavelength, the greater the frequency, the greater the energy of light. So radio waves, right? wavelength of over 1,000 meters. It has very low frequency, so low energy. Right? So radio waves is the realm of transmission that your mobile phones use. Right? They're not going to cause you damage by having it next to your head because it's a low energy waveform. Right? Once we start to reduce the size of the wavelength, we increase the frequency. So infrared light, 600 nanometers. Right? Now we're increasing the
Well, aren't radio waves dangerous if you keep your phone in your pocket?
not enough energy. Right? Well, nothing's been shown yet, right? Low energy waveforms.
Yeah, and like fries your spam.
Not enough evidence, right? Ultraviolet light, 400 nanometers, so we're decreasing the size of the wavelength even further. High energy light, which is why ultraviolet light burns your skin. Yeah? Which is why they use that bluey violet light when you get a filling at the dentist.
Is that what seals it?
Yeah, so the light is higher amounts of energy that helps to activate the reaction. Okay, cool. So what I want to highlight is that only one of the hydrogens is substituted with the halogen, right? Not both. So we don't get either of these two products. Now, in reality, if we keep supplying more ultraviolet light, the other hydrogens will subsequently be substituted. But for the purpose of VCE, including Year 12, we're only going to substitute one. Got it? Cool. Now, if we take that haloalkane and introduce a nucleophile, we get what's called a nucleophilic substitution, right? Chlorine, or halogens in general, chlorine in particular, is known as what's called a good leaving group. What does the word leaving mean? To leave, yeah, to get out, right? So if I said leave the classroom, what would that mean? Get out. And I want to replace you with someone who is stronger and more interested in their learning. Right, so chlorine is a good leaving group. Hydroxide is a good nucleophile. So the hydroxide comes in and the chlorine pops off. Got it? Another thing to notice is there's no reaction condition. So we tend to write our reaction conditions above or below the arrow. There's no reaction conditions. It's spontaneous. This will occur anyway. Now, if I take that OH and combine it just with an alkane, nothing will happen. Got it? So I need a chloro, I need a haloalkane in order for the hydroxide to attack. Any questions on that? Cool? No? Yes? All right. I'm going to ignore this because we don't look at amines this year. I can also use water as my nucleophile to produce the same product. The difference being that I need a catalyst in order to progress this reaction. Cool? So chloroethane, chlorine gets replaced by OH. And the byproduct will be Cl minus, or HCl in this case. Cool? All right. Question? Include sound? Yeah, they should be included.